Next up, we are joined by the wonderful Daphne Liu. Daphne is a regular at the SeattleJS meetups and works at Grow Therapy. I think one of the funnest facts that I have about Daphne is that back in the olden days, she was the co-founder of essentially a Keurig machine for bubble tea, nicknamed the Boba Bot. This was in college. It never got to production, but I'm a little jealous because coffee people get to enjoy coffee and making tiny little bits of waste to clutter the planet with. And as a tea person, I'm like, where does my waste come from? Where do I get to inflict my caffeination pleasures on the world for future generations to endure? Anyway, I hope the Boba Bot will happen one day. If anyone's watching on the live stream who's got money to invest in this, please, Daphne's amazing. And also an actor in the local thespian scene. Do catch her on stage.
Thank you so much. Hello, it's me, Detective Daphne. In case you haven't heard, there is a murder in town, the murder of passwords. Somebody reported finding the body of passwords floating on the internet, and today we are going to solve the mysterious murder of passwords. So how do you know if you can trust me? I got credentials. I'm an incoming front-end engineer at Grow Therapy, and I previously worked at Lyft, Shopify, and Yelp. I perform improv and I write sketch comedy, meaning that I am physically incapable of giving a conference talk without doing a bit. I don't know how many Daphnes you met in your life, but on Twitter, I'm the better Daphne. Without further ado, let's head over to the crime scene. It was a dark and stormy night when the body of passwords was discovered. Upon looking at the results of the autopsy, it looks like passwords suffer from a case of lack of security and human forgetfulness. And the murder weapon is passkeys. Passkeys are a replacement of password that the user sign in using their device lock screen. They make biometric login systems like Apple Touch ID and Windows Hello available to the web under a single unified API and branding. So instead of having to remember your passwords, imagine that you can log in everywhere in the future using your biometric like your face, your fingerprint, or however you usually log into your phone and your desktop. And you guys are in luck. I found some security footage of how passkeys work. Let's say I am an Android user who's trying to sign in into this app called TriBank. So I open Chrome, and I type in my username, and type in my passwords, and sign in as usual. And now when I'm logged in, I am prompted to create a new passkey. I select that option, hit continue, and continue again. And now I can use my fingerprint to verify. So the next time I am logged out and want to come back in, I can skip the part where I have to type in the passwords and continue. And now I can use my fingerprint to do that. And did you guys see how fast that was? That had to be 7 seconds. And what happens if I want to switch over to a different device? Say if I want to sign in using Edge on Windows. I can reuse the same passkey that was created on the phone. So here I click on Sign In and add a new Android phone. And when this QR code appears, I can open the camera app on my phone to scan. And make sure that your phone is nearby because here we're using Bluetooth to make sure that you're physically present. And now I just need to scan my fingerprint. And now I'm signed in. But if I don't want to pull out a phone every single time, I have the option to also create a passkey on the desktop. And since I'm using Windows, I can do that by using Windows Hello. But if I switch over to a Mac, it is the same concept. Safari has the ability to also present this QR code, and I can use my Android phone to scan the code in a similar way. But let's say if I want to ditch my Android phone for an iPhone, which I personally would never do, the magical thing is that passkeys are synchronized to my iCloud account. So the passkey that was available on Mac is now automatically available on my iPhone if I'm logging using the same Apple ID. There is no QR code scanning needed. And here, I just log in, and TriBank knows that it's me. It would have worked the same if I was switching between different Android phones, because passkeys actually can be synced using Google Password Manager. And Chrome OS and Windows don't support passkey yet, but that will likely come in the future. And other password managers like Bitwarden and 1Password are working on letting you store and sync passkey across multiple devices. But all the options I talk about have something in common, which is that they all support letting you scan with QR code so that you can reuse another passkey for another device, no matter what the operating system. In terms of security, if we think about passwords being the least secure all the way to the left, passkeys fall somewhere between two-factor authentication and hardware security key. And that's because two-factor authentication can be susceptible to phishing because your text messages can be intercepted. And I know that there is another part of the two-factor, which is your password. But since passwords are so insecure, it doesn't add much to the security of the 2FA. On the other hand, you got your hardware security key, like your YubiKey. And they are so secure because the hackers would need to physically obtain your YubiKey. Passkeys, they are automatically generated, and they are not shared between different websites. And they rely on this concept called the public key cryptography, which I'll touch on later. But what it does is that it makes it phishing resistant. Despite the fact that hardware security keys are more secure, passkeys offer much better user experience. And again, going all the way from the left, 2FA, you have to pull out a phone and grab your one-time code. It's not very convenient. For password, you have to type in your very complicated, randomly generated password. And for your YubiKey, you have to carry around this tiny device that is so small and so cute that I just want to lose it all over. With passkey, there is nothing to remember and nothing to carry. There were a few suspects arrested at the crime scene. We have FIDO Alliance, a nonprofit that develops authentication standards to move the world away from passwords since 2013. And we also have their accomplices, Microsoft, Apple, and Google. And actually, all these different companies just roll out their passkey over the summer. So this is rather recent news. And look at you guys. You guys are staying on top of the latest and the greatest technology. You're welcome. So this is where the analogy falls apart. You know how people say, don't try the murder weapon at home? I said, definitely try the murder weapon at home. Share with your friends. Run around in your living room with it. And I will show you how. So let's learn about how passkeys work. I'll teach you how to support them in your websites, but I will be focusing on translating these mechanics into plain English to make them approachable and agnostic to the particular device and libraries you choose. So no matter what your front end or your back end look like, it will work for you. And whether you're working on this to support them in your personal projects or at your company, hopefully you'll find this useful. So our suspects are really sneaky. They made sure to encode their documentation online with all these technical jargon to make them very difficult to decipher. But don't worry, I have decoded them into plain English, but I also made sure to leave all these technical terms on the screen as AKA to make your future Google sleuthing easier. So passkeys, they are secure because they are built with public key cryptography. Let's define some terms first. Encryption means that you're taking some message and convert it into some unreadable gibberish. And decryption means you are taking that unreadable gibberish and convert it back into its original message. And this ensures that the message stays only between the sender and the receiver. And public key cryptography is a way of doing that. It's a system where you have two keys. One key stays public, like your mailing address, and the other key stays private, like your physical mailbox key. And this way, if someone wants to send you a message, they can encrypt it with your public key, and only you can decrypt the message because you're the only owner of the private key. And that way, you can hand out the public key to everyone on the internet, but they can't do anything about it without the other key. This also works in the opposite direction. Say if you want to send someone a message, you can encrypt it first using your private key, and someone else who has your public key can decrypt it. And you might be thinking right now, no, that doesn't sound right. You just told me that everyone has my public key. Doesn't that mean everyone can decode my message? And the answer is, it proves your identity. It proves that you are the person who sent the message because only you could have encrypted the message in the first place. And the flow we talk about first is the most common use case of public key cryptography, of encryption, but passkeys built on top of the flow on the right. For passkeys, the public key is shared with the server, and the private key is now stored on the user's device's login manager, very verbose. And to illustrate, I have written a fanfic for if I, the user, tries to log in, and it goes something like this. Interior, night, Daphne runs into the server. The server says, hey, never seen you here before. Am I gonna see you here again? Well, here is a padlock for you to remember me by. Time passes. Daphne runs into the server again. Daphne, is that you? Yes, of course it's me. And let me prove my identity by unlocking the padlock with my private key. Oh, I recognize you now. I knew you'd always come back for me. And sing. So how do we achieve this using JavaScript? Well, there is an API called the Web Authentication API, or WebAuthn for short, that generates public and private key for login. And you might be already familiar with WebAuthn if your app already supports hardware security key. And in fact, if that's the case, your app will automatically support passkeys as well. And that is the most common use case of WebAuthn right now. It's used as a second factor to supplement passwords. But thanks to the development of passkeys, WebAuthn is moving towards being the only factor to completely replace passwords. So how can you add passkey support to your web app? Let's cover two flows, registration and authentication. Let's start with registration, or creating a new passkey. Here's a video of how to create a passkey. And in this example, the user is already logged in on desktop, and they're adding passkey for the first time. The modal appears, and they're using their fingerprint to create a new passkey. And once they're done, the new passkey appears in the account settings page. The user can't even see the content of the passkey, because if there's one thing you and I agree on, we don't trust users. And we have 4 separate components in the diagram. We have the user, the web browser, front-end, and back-end. And I'm going to collectively refer the front-end back-end as your app or your website, or the technical term relying party. Let's say you're the web developer and I am the user. When I click on a button on your front-end to add a new passkey, your JavaScript code makes a fetch request to your backend telling it, I want to register. And your backend replies by asking for a public key with some options. Your frontend then tells the browser that I want to create, it tells the browser to create a key. And the browser will first ask me for biometrics. Once I verify my identity with my fingerprint, the browser creates a public-private key pair. And it stores the private key with the operating system's password manager, and then return the public key to your front end. And then this public key is then forwarded to backend for storage. And notice the separation of responsibility over here. The user never sees either key, and your website only sees the public key. So here's some sample code for the front end. And don't worry about taking photos right now. I'm going to share the slides later, I promise. And at the bottom, we create an add a new passkey button, which calls the method register passkey. When we send a fetch to start registration, we expect the backend to return a public key credential creations option object. And this contains the options required to create a new passkey that's tied to this website. We then pass the options to navigator.credentials.create, which is a part of a WebAuthn API. And this instructs the browser to ask the user for biometrics. Once the browser is done verifying the user and creating the pair, navigator.credentials.create will resolve with the new public key. And your website will then send it over to a server for storage. During registration, this is the object that the backend creates. And there are two parameters I want to call out, which are the challenge and the RP. And I think of the challenge kind of like session ID. Each time you start to log in, it creates a new session ID. And every time you finish logging in, it closes a session. So if someone later tries to copy my login request and send the same data back to the server, the session will already have expired. And this prevents something called the replay attack. And the challenge is randomly generated by array. RP, or relying party, contains the information about your website for the passkey. The ID part corresponds to the website origin. If the ID doesn't match with the origin, WebAuthn is going to throw an error. And this prevents phishing because only the real website can create a passkey with this ID. Now that we have created a passkey, let's see what the login flow looks like. Here's a return user who's signed out but has a passkey registered on the device. They click on the button, and this built-in modal appears. The user touch ID is successfully logged in. This modal flow works, but is not the recommended flow by W3C, and that's because passkeys just aren't popular yet. So it's really hard to describe it to a user in a way that's intuitive. And instead, W3C recommends another flow, the autofill flow. In the autofill flow, when the user clicks on an input, they're presented with a list of possible saved passkeys for the website. They select the option and verify using their fingerprint. And this flow looks very similar, right? It looks very much like a password manager. And in fact, if the user has saved password for the page, they'll be shown in the same list. And I really like it because it integrates seamlessly into a flow that already exists. Now, authentication flow follows a similar idea with registration. When I click on Sign with Passkey, your front end tells your backend that I want to log in. Your backend responds by asking me to sign some data. It's like asking me to open a padlock. Your front end then tells the browser to sign the data with my private key, and now the browser will ask me for biometrics. Once I verify, the browser will grab my private key and use it to sign the data. And we call this signed data signature. The signature is returned to your front end, which is then forwarded to back end. But instead of storing it this time, what it does is that your backend is trying to decrypt the signature using the public key that it previously stored in the database. If it matches the data that it asked to sign in the first place, it proves my identity because I have the correct private key. And now I'm logged in. We'll go over the sample code for both the modal and the autofill authentication. They're pretty similar, but they have some differences. We'll start with the sample code for modal. At the bottom, we create the sign in with passkey button, which calls the method login with passkey. When we send a fetch to start authentication, we expect the backend to return public key credential request options object. And note that this time, it's request, but not creation like before. So this object contains the options required to get existing passkey that's tied to the website, including the data to sign. We then pass these options to navigator.credentials.get, and this instructs the browser to ask the user for biometrics. Once the browser is done verifying and signing the given data, navigator.credentials.get will resolve with not the public key this time, but the new signature. Your website then sends it over to backend for verification. If the signature is valid, then you can proceed with signing the user. The code for autofill is similar but has a few differences. For example, we run our function as soon as the page loads, instead of waiting for the button to be pressed. The function also has a feature detection check, so we don't run it for browsers that cannot display the passkey autofill. We pass option mediation : conditional to navigator.credentials.get, which is only used for autofill flow. The promise it returns will be pending until the user chooses a passkey option in the dropdown. And we can specify where the dropdown should appear by adding in the word WebAuthn to the autocomplete attribute on the input. Now let's take a look at some backend code. When we start authentication, your backend will create a public key credentials request options object, which looks something like this. Note that it has fewer fields this time, just RP-ID and challenge. RP-ID is going to correspond to rp.id, which is what you saw in the creation options, and they should match. And challenge, again, is a randomly generated by array, although this time it should not match because, as we said before, the challenge is generated every single time authentication and registration starts. And I know we keep on talking about how the backend sends some data for encryption. And we also talk about how the private key is used to encrypt some data. And then the public key is used to decrypt it to check that whether it matches. But what exactly is being encrypted and turned into a signature? The answer is a lot. We have the origin, we have the challenge, the encryption algorithm, and many things I'm not even including here. And all this comes together to form the signature when it's signed by the private key. When we send the signature to the backend, it will see a couple different fields. We got two separate byte arrays that represent the data before the encryption, and we have another field called signature that represents the data after the encryption. The first field, client data JSON, gets hashed and concatenated with authenticator data, and this becomes the data that gets signed. And finally, the backend decrypts the signature using the public key to verify that it matches. Now, I know that we've been trying to solve this murder mystery really quickly, and just like any true crime podcast, I'm only here to give you the juicy details. So lots of things were oversimplified, and in this case, I really recommend that for your backend, you use the existing library for verification. And here's a list of libraries you can look into in different languages on webathn.io. Now that we have learned about what passkeys are, we understand that it's one, more secure. Passkeys are bound to the website origin, meaning that it's phishing resistant. And two, it's familiar. Users are familiar with the autofill UI, and I'm sure users are thrilled to not have to carry around an external hardware. And three, faster. According to my very unscientific calculation, it takes 7 seconds to register and 3 seconds to authenticate. And I hope that this talk is here to serve as a starting point to pique your interest to learn more about passkeys and see if you can incorporate it in your current system. And here are a list of resources that I found to be incredibly helpful during my research, and sharing is caring. Well, thank you for solving the mysterious murder of password with me. Upon looking at all the evidence out there, I have concluded that the true killers of passwords are you, web developers, for making signing experiences better. If you have any future murder mystery to solve, like third-party cookies or any of the Google products, feel free to contact me on Twitter or on LinkedIn. And here is the link to the slides that I promised. And if you see me around the conference, feel free to say hi. I love to make new friends. And with that, the case is closed.